Hello guys, you are welcome back. In today's video, we are going to be talking about introductory calculus. Calculus is a branch of mathematics that is introduced by Leibniz, Faraday, and Newton. And we are going to start our discussion by considering the gradient of a straight line. We have here here is a graph that we want to consider. You see, when we talk about gradient also means slope, and it is expressed as rise over run. Gradient. Let me start by saying that gradient is equals to rise all over run. And if you look at this graph, the rise is y and the run is the horizontal. The rise is the vertical and the runs is the horizontal. So if you look at this graph, I have y2 in this place, I have y1 in this place, and I have x2 and I have x1 and x2 as the runs. Now if I want to use this to if I want to denote my gradient considering this graph, I'm going to have gradient. Let me represent gradient as m. M is equals to y2 minus y1 all over x2 minus x1, because this is also the same thing as change in y all over change in x. That is, change in y, change in the distance between this point and the distance between this point. That is the gradient. Now when we have m is equals to delta y all over delta x, anytime we limit delta x to as x tends to 0, then we are going to have dy all over dx. So now we have known the formula for the gradient of a straight line. This is the formula for the gradient of a straight line. M is equal to y2 minus y1 over x2 minus x1, where y2 minus y1 is change delta y, which is change in y, all over change in x. Now we are going to use this formula to compute the gradient of a straight line of two given points. Let's start by considering the application of this formula, y2 minus y1 over x2 minus x1. Let's assume that we are given a question: find the gradient of a straight line passing through the points 2, 3 and minus 4, 5. Find the gradient of a straight line passing through the points 2, 3 and minus 4, 5. The first step is to identify your x2 and x1 and y2 and y1. Now look at this. A point is always have x, y. So this given point is x, y. So this one will be what? X1, and this one will be y1. And for this is x2, and this will be y2. So we have identified the x1 and y1 and x2 and y2. The next step is just substitute all this into this formula. So m, which is the gradient, is equals to y2. Don't forget that y2 is 5, so I'm going to have 5 minus y1. Don't forget that y1 is 3, so I'm going to have minus 3 all over x2. x2 is minus 4, so I'm going to have minus 4 minus x1. x1 is 2, so minus 2. So m is equals to 5 minus 3, that is 2, and all over minus 4 minus 2, that is minus 6. So I'm going to have minus 6 in this place. M is equals to 2 divided by minus 6, that is 1 over minus 3. So I'm going to have minus 1 over 3. Of course, this m is equals to minus 1 over 3. So the gradient of the line joining this point, the gradient of the straight line joining this point is minus 1 and minus 1 over 3. Let's have another practice question. Let's assume that you are told to find the gradient of a straight line joining the points. Let me call this P, 1, 6 and Q, 2, 4. So find the gradient of a straight line joining these points. The first step is also to identify our y2 and y1 and x2 and x1. Don't forget that at every given point we always have this coordinate x, y. So for this one will be x1, and this one will be y1, this one will be x2, and this will be what? Y2. So after identifying x1 and y1, x2 and y2, we can proceed to use this formula that we just derived, which is y2 minus y1 over x2 minus x1. The gradient m is equals to, don't forget that y2 is 4, so I'm going to have 4 minus y1. y1 is 6, so 4 minus 6 all over x2 is 2, and x1 is 1. So 2 minus 1, that is m, is equals to 4 minus 6, that is minus 2, all over 2 minus 1, that is 1. Oh, so the gradient is equals to minus 2. So the gradient of the line joining the point P 1,6 and Q 2,4 is minus 2. Now let's have another practice question. Find the gradient of a straight line joining the points A, that is 5,8, and let me call this 2,3. Okay. Find the gradient of a straight line joining this point. If we want to calculate the gradient of the straight line joining this point, we are still going to use this formula, and the first step is to identify the y2 and y1 and x2 and x1 respectively. So don't forget that every coordinate always have this x, y. So in that case, this one will be what? X, and since this is the number that came first, this will be x1, and this will be what? y1. This will be what? x2, and this will be y2. So in that case, we can proceed to use this formula by just substituting all the parameters that we have here. So m is equals to y2, which is 3 minus y1, which is 8. So 3 minus 8, 5, all over x2, which is 2. So 2 minus x1, that is 5. So m is equals to 3 minus 8 is minus 5. Oh, sorry. 2 minus 5 is minus 3. So the gradient of a straight line is minus 5 over 3, that is 5 all over 3. The gradient of a line joining these points A and B is 5 over 3. So that is how to calculate the gradient of a straight line. Thank you very much for watching the video. We have come to the end of today's lesson. Thank you very much.